Hello, good evening. How are you? Happy to see you. Good evening. How are you? Okay. So, how clear is this place? It's very clear. Okay. Yeah. Sorry? Yes, my laptop. Okay, down. Okay. Yeah. With Zoom. Okay, yes, I can see it. Okay, I have not tried this approach before. So let me see if I can share with you from here. It didn't show me the link to connect to. Okay, I should open it on the system. Okay. So let me look at. Okay, so I want to open the slide now. Can you see it now? Okay. Okay. So how will I be controlling it now? But I am not seeing it here. Well, okay. Maybe I have to just go off from the video, then stay with the slide, right? Yeah. Yes. I can see it too. Yeah. So I think this is fine. Okay. All right. Okay. Yeah. So what what are you using it for? My face is rough. Oh, fine. Okay. Okay. All right. Yeah. Okay. Let me just say a final word. I didn't sign up. I didn't have as in the final slide where I will make my final comments. But no problem. Oh, fine. This presentation is 45 minutes, right? Okay. The timer. No, I can't see timer, but you have disappeared. I can't see the timer. The only change is that you have been blinded. You've been blinded and nothing else. Yes, the timer is here. Yes. Yes. All right. It's okay. No problem.
Okay, guys, we are live again to continue the second session. How was the break? We have Dr. Solomon Chollom already online waiting to take on his session. If you can hear me, please, can you let us know from the comment section that you can hear us? If you can hear us, let us know from the comment section that you can hear us loud and clear. We're live now, sir.
All right. So am I?
No, I'll tell you when to come. Or we're live.
All right.
Yes.
Okay, fine. Thank you.
As soon as people start coming on, I will engage you.
No problem.
So if you can hear me loud and clear, let's read from the comment section so that we'll begin immediately this second part of tonight's meeting.
Okay, from my end here, right? Okay, I am actually in my lab, so somebody is in. talking around. Let me shut the door. Yes, let me shut the door.
Maman,
Yes, sir.
I know.
Yes, sir.
Now stress the worry you. I did feel cool. Yesterday, you know it was drizzling. I didn't come out at all.
Okay.
So I was feeling cool. I just said maybe this tiredness. This morning again, I can't see one strength. You understand?
Yes, sir.
I can't see strength. Make that come out. Now I can't feel.
Okay, again. Okay.
So make I do tell the father to take anything. You know that's how we do.
Yes, sir.
Let me say it.
Just a second. Okay, so
Okay, no, I want to do my leather test.
yes. Can you give me like 1 hour? We're about to start. I'm about to start a training now.
Okay, for somebody.
Yes. A group of people actually.
So if I come there, you come. It's just
I
like-
am the guest speaker. So
Can
just
you
one.
just take the sample so that when I come,
Okay.
please let me go to that chapter because I know how I'm feeling. I want to take malaria drugs as a risk.
Okay, so Elvis. Okay, so by 15 and by 6:15 we'll be live. Okay, fine. I have like 9 minutes.
Okay. So this one can also.
Sir?
This one can also be that I collect somebody dash me this and say I want the bigger one.
This one does a lot of magic.
Oh,
I have held reward channels news. They will connect people from outside. From here, I've granted a lot of interviews to channels, AIT.
wow.
They were interviewed. Yes. Even like most of them, but they have just started for AIT. You know, like I told you now, my work was on Lassa fever.
Okay.
So,
Lassa product, how many code? Now this is malaria one.
Lassa fever and Corona.
Okay,
They are,
that's corona.
yes, they are very close.
Okay. Like I just see my best. Oh, they are very strong.
So let's look at malaria. How is the problem?
I think when I came back to the I just moving up and down. I tell you from Lagos.
Well,
I went from
so now how's it
Abuja.
going?
I went to Cape to Makoti. I take 3 days in Makoti and now I have to go back to Abuja. That same day I come back. That is when I pick from Benarisha, we are back from Okoli. And I drive back to the journey.
But you did that treatment, huh?
Yes, that is when. Actually, the man said, even I didn't take anything.
Yeah,
It's a little exercise I'm doing.
very well.
Sometimes the drugs do react with our body.
The environment,
What you
that's
know? That's not we shout.
because this body is human that like lots of
Oh, you do shit.
so those of the yes, there
There are some of the counter drugs too.
Okay.
But our own was for our own was we did we needed blood just to take blood. That was how they do it. Yes.
Like this one.
Just like this one, sir.
You know, you trick me. See, there is a way you trick, you understand? You know the tissue is close by.
Yes, sir.
When you reach the tissue, when you find the tissue, you must run it in.
Sure. But it's a charge that we try.
And that's what I'm saying. I think you were a child now. What does mean? I should wait, or I should go and come. Like, I should not take the drug straight. So I will be sleeping. You know my house now?
Yes, sir. You told me it's down that house.
With the silver gate.
Yes, sir.
I'll come before like 7:30 before this girl close.
Sure. Just by 7 o'clock, I should be done.
Yes, I am. Okay. All right. So, all right. So, should we fire on? All right. So, good evening, everybody. It's glad to have you here, and I want to commend this initiative. And in the next few minutes, I will be discussing with us the role of medical laboratory scientists in vaccine production. And I'm sure you understand that this is a significant area that we cannot toy with. The preamble, or rather the content of our discussion, we'll be looking at what a vaccine is, and then how important are medical laboratory scientists in the production of the vaccine. And we'll conclude by looking at what AMSIN and what Medical Laboratory Science Council of Nigeria needs to do to promote the production of vaccines in country. By way of definition, we're all familiar with this, that vaccines are biological preparations that provide active acquired immunity to an infectious disease. These are not strange terms to us. Active and acquired immunity is different from either passive or innate immunity. So in this case, vaccines provide us active immunity. Active immunity differs from passive. In passive, is mostly accidental, either from mother to child, but in active, is either through vaccination or through natural infection. So, but critically is for us to understand that they are biological preparations, meaning that they are prepared in the laboratory and they are very specific against the organisms or the diseases they are prepared against. We will be looking at this in the process. But permit me also to add that the reason for vaccination is to up or bolster the immune system so that it will augment its fight against infections, most specifically to make it resistant to any microbial infection. This, is the theory behind it. There are different types of vaccines. We have the whole organism or part of it, as it were. Others categorize either as attenuated or as inactivated. So the vaccine we'll be looking at are in the category of those that have the whole or the entire organism, and those that also have just components of it. So for those that have the whole organism, we have the either life attenuated. We are familiar with these words. In attenuation, the strength of the organism has been reduced. Most times, what has been brought down is the virulence, but antigenicity is maintained. So virulence is the ability to cause harm. That has been brought down by reason of attenuation. Processes are like chemical or otherwise. There are the inactivated or killed vaccines. So they both radiate around viral and bacterial vaccines. There are other forms of vaccines that are more of macromolecules. The polysaccharides, the toxoids, we are aware of the antitetanus, serum. It's a toxin of the organism that is purified and, standardized to be able to elicit certain immune response. We also have the recombinant antigen and then the recombinant vector. Where you see a vector, it's serving as a vehicle wherein it carries whatever is to be conveyed to the host system to elicit the immune activity. So the whole organism and the purified microbes, they serve as the basics or the conventional vaccines, as it were. But we have the new generation vaccines, which are molecular based. So there are DNA vaccines, and then there are also the synthetic peptide vaccines. The DNA vaccines, they are the unconventional ones because in this case, you are not talking about the organism as a whole, you are talking about the gene, how it can be manipulated and enhanced through the use of vectors to carry out some activities. In synthetic peptides, most times is where you have the reverse vaccinology, where instead of looking at the host, the organism, you look at the host. Sometimes you look at the organism as well, but with the use of bioinformatics, make a snapshot of certain components of the genes that you have discovered to be responsible for augmenting the immune response. And then you go back and synthesize, a replica of that, which you now use to, administer. Permit me to also talk about the basic process. The conventional vaccine is such that the process runs, in a unique way. You have the organism of interest. For example, the COVID-19 virus. In this case, let's say it's a killed vaccine. So you must have killed it either through heat inactivation or chemical inactivation. But if it is an attenuated vaccine, hello, yeah. So if it is an attenuated vaccine, you bring down the virulence by several forms of passages. Now, so what we have here is a pictorial of the cell culture based vaccine. You introduce it in a medium. Cell lines, it must have undergone those initial preparations from the wild form into the mild form. I have always defined the process of vaccine development as, a way of turning the wild into the mild so that the mild can turn around to tame the wild. So those are, pre-vaccine production, steps that are taken. So it multiplies, and then you have it in its numbers. The organism is in its numbers. You are able to now do a harvest of this, and then through processes of titration, safety, test, sterility test, potency checks, you are able to, concentrate this, and what you will now have are your ampules, just like what you have here, and ready for use, in the field. We are going to also talk more on this in the process. For the non-conventional vaccines, like I have hinted, before now, in the DNA vaccines, what you have is a situation whereby, a particular gene of interest is, extracted and, made to be incorporated through a plasma, a plas a plasmid. A plasmid, serves as a vehicle to convey it from one, macromolecule to another. So in this case, maybe into the phages because of their rapid multiplication, phenomenon. So the moment is deposited there, the new host has the ability to replicate that same strand or that same portion of the gene. And because of the frequency, the high frequency of multiplication, you are able to have several copies within a very short time. And in the process, the very minute portion that you put in here, grows to be large, and you can now collect this along with the host genome, and you purify it here and extract just your own portion of interest which you have, incorporated there, and you have it just here. So this is basically the principles for DNA vaccine production. Now, for the reverse vaccinology that I have talked about, I want you to pay particular interest to, the fact that it starts as a DNA activity, a PCR-based activity, but it now dovetails into bioinformatics, wherein you select, particular alleles of interest that you feel are responsible for the immune sensitization, the immune buildup. And what you do there is that you are able to do a selection of that, from the B cells, the T cell population. You are able to now have them, replicated, and then you synthesize them. Then you can quantitate using your molecular techniques to be sure you have gotten a sufficient concentration, and that is what is being administered. So these are advances that have been done, in vaccine production, as it were. Now, the basic question that we want to ask is, why vaccine production? Why are we talking about vaccine production as a country, or as, this LEADMedLab, group? I have this from literatures, and I want you to look at it very critically. Now, if you look at HIV-1 subgroup M, it was discovered in DR Congo in 1920. If you look at Zika virus, it was discovered in Uganda in 1947. If you talk about Lassa fever, it was discovered in Nigeria in 1969. If you talk about Ebola virus, it was discovered also in DR Congo in 1976. Then the guy of the moment, SARS-CoV-2, with its cousin SARS-CoV-1, were discovered in China in 2019 and 2003, respectively. Talk about the H1N1 influenza virus that, plagued the world in 2009, right up to 2011, thereabout, was discovered in Mexico. Then meningitis type C in Nigeria again in 2013. Now, what is of interest to me in this data is the fact that most of the diseases that have ravaged the world in recent times have their roots either in Nigeria or in Africa. If you take off, the H1N1 influenza virus and the SARS virus, you will discover that all other ones came from African countries, and Nigeria also inclusive. Now, this is something to ponder on, to the fact that as much as this is a threat to us in Africa and in Nigeria, it's a potential as well. It's an advantage because, like from my, the pedestrian definition of vaccine, which I say that is, making mild the wild, so that the mild can turn around to tame the wild. So without the pathogen, you cannot talk about vaccine development. Without the pathogen, you cannot talk about the development of either rapid test kits or molecular based test kits. So much as we are having these viruses around us, it gives us an edge to lead. We are talking about LEADMedLab Africa. it it gives us the leverage to take leadership, as it were, in vaccine production, in vaccine development. But the challenge has always been that lack of infrastructure, lack of will, lack of impulsive moves, as it were, by our leaders to bring this to bear. And so we are always left with the challenge of transporting these samples outside of our continent, outside of our country, elsewhere. And except for the blessing in disguise, as it were, from corona, that we now have molecular biology labs all over the country. Before now, diagnosis is limited. As so most researchers take their samples out, and in the process you only do a fraction of what you're supposed to do, while the entire material, the entire biological material stays there. Some people don't even travel along with these samples, they send them. The white man there will give you the result of interest and proceeds to use this organism for other stuff. So we have the advantage of these organisms here, but the other negative part is that we have been severely plagued. We have been, like the hot spot, as it were, of emerging and re-emerging infectious diseases. So our people die, every now and then. The challenge is always there, and so this must give us a poser. I was listening to the talk of Elvis, earlier. He was talking about the fact that we must be able to identify our own problems and see how we midwife solutions for those problems also. Another point is the fact that we spend a whole lot on importation of vaccines. Nigeria used to have a human vaccine production laboratory, but no more. Now, for the past 26 years, we have been importing vaccines, and you can see where we are importing these vaccines from India, from Korea, from Russia, from Belgium, and all of that. But the news here is that conservatively, Nigeria spends about $5 billion annually on importation of vaccines. And there was a surge in 2003 where the number doubled to $11 billion. Now, I said for the past 26 years, our vaccine production laboratory has been moribund. Now, if you multiply 5 billion by 26, you will have $130 billion. We are not talking about billion naira. We are talking about $billion. And you can only imagine how many vaccine production laboratories, how many public health laboratories would this money, have been, put in to revive our health system in the country. So this has all gone into capital flight, and it is, one of the reasons why we need to take leadership in this, sector. Now, before I talk about the role of medical laboratories, the medical laboratory scientists in the production of vaccines, I want to give us, a brief rundown of the vaccine value chain, as it were. Now, vaccine production does not just happen. It starts from somewhere where I want to call, the pre-production stages. And, that has to do with defining what the threat is. And that is where you have a lot of surveillance activities. There is a strange disease, so a lot of surveillance has to be done. A lot of search has to be done so that we will be able to to identify what the cause of this disease is all about. And after that, we will be able to bring to bear that, okay, what is plaguing us is coronavirus. But then, is it just one strain, or there are several strains? So that surveillance activity will bring us in. Then there is the development stage, the vaccine development. Vaccine development is different from vaccine production, and where the rigors is, or where you have the major challenge, is in the development. The development of a vaccine takes a lot of processes. That is why up to now we are still, begging for time to come up with a vaccine for corona, for Lassa, for HIV, and all of that. The processes are rigorous. They come with a lot of safety issues. They come with a lot of, issues around potency and all of that. Vaccine production is the third in the chain. Vaccine production is just a mere routine. What you have is that during the vaccine development stage, the protocols would have been defined, would have been established, would have been standardized, and then that is what you will now use. For example, if you are doing gram staining, you don't need to crack your brain. The protocol is already there. You just follow it and you walk, the way. But the person that developed the protocol for gram staining did a whole lot of work. So the challenge is always in the vaccine development, then the production, then the supply chain, and then the other processes that fall through. So it is essential for us to understand, this, chain, so that we will be able to place ourselves where our roles are. Now, in vaccine development, just like we have said, there is a lot of surveillance activities. What you are doing is that you are doing a lot of antigen, you are doing a lot of gene, you are doing a lot of epitope editing, depending on the type of vaccine you want to produce. So which one is the antigen of interest? You have to keep sieving, you have to keep selecting. Which one is the gene? Which one is the epitope of interest? Which one is the allele of interest? The same thing goes to, the microbial antigen edit. What you do is what we call vaccine C selection. In that process, you are passing this, wild organism through processes that will tame it. You want to make friend of it. So you have to be, magnanimous, as it were, in the way you treat it, so as not to lose it in the process. So a lot of activities in terms of passaging, in terms of treating with chemical, in terms of shifting it from what used to be very harmful to what you can now embrace. Then optimization of microbial load. this has a lot of telling in the integrity of the inoculum. What standardization are you doing to be sure that you are not underseeding, you are not overseeding, you are not doing less or more in terms of the microorganism, the load of the microbes that are there. Then you talk about sterility checks. This is very important so that in the process of administering a killed form or one form of organism, you don't introduce another. In vaccine research and development, you do a lot of other activities. Your assessments of the production platforms. What platform are you going to use? Is it the embryonated eggs? Is it the fermenters for bacteria? Is it the plasmids? Is it the phages? Or what particular gene are you going to use? Then, of course, the surveillance activities are there. You are checking out what do we have here and how do we blend this. There is an aspect of antigenic pooling. For example, you are doing a compound vaccine. You want to pool all the available antigens around. That is also very necessary. So you must keep tabs of what is around. One of the major reasons to vaccine failure is inability to capture all the necessary antigens. So you find out that when one is missed, you come back and what you're having is poor response of the immune system in building up the immune capacity to ward off these organisms. And of course, we cannot let off the issue of the organisms themselves doing mutation. And that's why a long term of surveillance and antigenic screening is very, very necessary. Um, the last point here is assessment of the production platform, especially with regards to what is going to be used. If you take a look at the cell lines, there are certain organisms that are adaptable to specific cells, others are not at all. So this is also very important to be able to bring the right form of response in terms of yield of growth of the organism. This can stand in for our vaccine production pathway. The first chart above, in case you are using the embryonated eggs, what you do is to have a selection of the vaccine strain, which I've talked elaborately on that. And then you begin to subject it to the medium that it will grow. Now, that medium for its growth is very essential. For bacterial vaccines, you have the fermenters. For viral vaccines, it has to be living systems. So either embryonated eggs, either cell lines, and all of that. Then, after you have infected them, they must have grown and reproduced or replicated in good numbers. Then you do a harvesting. Now the harvesting is very crucial, and the process of doing that has to be with a lot of care in order to avoid the introduction of extragenous organisms. Then the inactivation of the organism eventually leading to the formulation, the compounding, and the quality assessment to bring about checking issues first of sterility, checking issues of potency, checking issues of adverse effects. What happens during the post-production activities? You still do a lot of these checks. There is the chemical aspect, there is the safety aspect. You are checking to be sure that what you are going to administer there does not constitute another harm in the event of trying to solve one. Toxicity is there, and all of that. So all of these give us the leverage to understand what our roles are now going to be. So let me look at the fact that in production, you also have issues that have to do with packaging and storage, post-production. So your work as a medical laboratory scientist does not just end in the lab. And this is where I am driving towards. Logistics is one aspect that we are not fully involved. And it takes a woman that cooks a soup, a well garnished soup, to be able to, understand the labor that has gone in, to also know how she must preserve it when her husband comes, so that she will serve it in a form that when he eats something, a strange smile will come out of his face. So if we concentrate on only the production and we are not there with the logistics, what is going to reach the end user most times is something that has lost potency, is something that is ordinary water. The last point I have, on that first slide is very critical. We do not have, you know, policy in country for quality assessment of our vaccines. We purchase these vaccines from foreign countries. We do not do quality, the quality checks our at the point of um, issuance of these vaccines. For example, you only see either a cake or a liquid. There is no check that is done to confirm its efficacy. There is no check that is done to confirm other aspects, and we administer, assuming that everything is perfect. After we have administered, we do not go back to check as to the population we have given polio vaccine. Have they responded sufficiently by the production of antibodies that will shield them against an exposure to polio? The people we have given measles vaccine, have we screened to find out whether they have developed the necessary level of antibodies, to shield them against an exposure? So we are working like blind men, and that is a big gap, it's a big vacuum that we need to occupy. We do not have public health laboratories, as it were, that are tailored towards, looking at issues around quality assessment of vaccine first before administration, to confirm their fidelity, to confirm their viability. And after we have administered, we also do not check the vaccinated population to be sure they have been protected. You take that baby to the hospital, or the people come and drop something in the mouth of the baby. Nobody does a follow-up to check whether the body has responded, and it's terrible. So other activities are virulence studies, to find out whether there is possibility of a reversal of the attenuated forms into the wild form. Then assessment of environmental risk. In case this thing drops off, is it going to cause a havoc in the environment? Interferences. There is a possibility that one valency of an epitope may constitute antagonism for another. Consistency of production. Nobody checks batch after batch, label after label. These vaccines just come, we consummate them. Stability. Who is checking the stability of the physical, the chemical, and the biological components? This is also a very critical aspect in logistics. It gives us, a wide range from the factory, the vaccine factory, up to the point of administration to that young boy in Haipan, that is in my village? Who is checking that? From the factory, maybe in India, down to Nigeria through an aeroplane, down to Abuja, down to Plateau State, down to my local government. What has happened? A whole lot, needs to be put in perspective. Now, coming down to what AMSIN and the council can do, there is a whole lot that needs to be done. First and foremost, how is our curriculum? Does it have sufficient space to build capacity in, vaccine production? Do we just mention it? And yet this is supposed to be our area. So how robust is it to support this new move? That's something that we need to ponder upon. Our postgraduate studies, can we begin to look at it? The council, can we begin to look at it that, okay, we need specialization in some of these areas? I listened to Auntie Nonye. She was talking about the need to have, capacity belts around biomedical and the biomedical engineering is very essential. So, can we begin to have people come up with, specific techniques or specific specialization around the area of vaccines? You have seen fellowships, in other climes tailored specifically around vaccines and vaccination. So it's very important that we begin to look at it. There is need to pay advocacy to Federal Ministry of Health and the National Primary Health Development Agency to highlight two principal aspects. One, the lack of quality assurance on imported vaccines. I have explained this. We cannot be treating vaccines as if we are buying food from the shelves or from the stores. Even food that you buy rice, you want to check it, whether there are stones or such things. But the moment these vaccines come, nothing is being done. You cannot rely on physical assessment of, just the vacuum alone. That is physical assessment. We need to find out the biological component. How active is it? What if, especially in this era of conspiracy of on vaccines, what if other things have been embedded in the vaccine? So this brings to for the fear of our people in certain regions of this country that some of these vaccines are meant to make them impotent. Of course, we don't have data to validate that, but have we got data to post that what they are saying is wrong? That is an aspect that we need to look at. So there is need to have public health laboratories regionally, if not at state levels, to ensure that we monitor these vaccines as they come. And then secondly, to do a steady monitoring of vaccinated population. We can't just be assuming that once given a jab, ever shielded. That must give way to evidence, as it were, in terms of the science that we are talking about. So public health laboratory for vaccine QA in the mold of IVD laboratory in pursuant to the Medical Laboratory Science Act 11 of 2003, we talked about especially section 4D that talked about the regulation, as it were, of biologicals that come into the country. So how are we regulating these biologicals? That place is a handicap, so we need to look at it. Then advocacy for the revival of the human vaccine production laboratory. So we are we are really missing out in terms of, this issue of vaccines. We are missing out a whole lot, and there is need to reconsider our stand, as it were. I will conclude by saying that the issue of vaccine production in Nigeria and our role is such that the industry has crippled and our people are bearing the brunt because we have long gone to responses through questions and contributions. Thank you. Yes, yes. Thank you, Elvis. Yeah. Mm. Evidence. Yeah. Yeah. Great. So, that's why I hammered a whole lot on the issue of quality assessment. Now, the conspiracies around 5G vaccines and all of that, and the impotency, and all of that. I forgot I would have included certain slides to let you see what even leaders of old, Mahatma Gandhi, there is this leader, this Sinkara, and all of that. What they said about vaccines. One of them said the greatest lie ever told humanity is that vaccines
Okay.
were safe. So, yeah, so the conspiracies about vaccines are not just coming up now, they have been there. But we, as medical laboratory scientists, we have always been the chief priest, as it were, if you take the health sector as a shrine. Now, the verdict that we have is that we are able to subject
Okay.
this to, chemical, biological
Okay.
assessments. Every vaccine that comes out, just like any other product that you get into your laboratory, you don't just start to
Mm-hmm.
consummate it. That is where the Nigerian government has failed woefully, and that is where, as an association, we have also failed
Okay.
woefully. We need public health laboratories to be able to do, specific works around
Okay.
vaccines. That every vaccine, whether produced in country or imported, must be shipped straight to those public health
Laboratories. Yes.
laboratories.
Yes.
They would have the capacity. They would have the capacity to check for the
Okay.
potency, to match it against whatever the producer has
Okay.
claimed. They will have the capacity to check for, I showed you areas around, virulence
Yes.
interference. Then issues of possibility of reversion to wild form. So these laboratories must check out these potentials. Issues around safety, issues around potency must be established there. And if there is any conspiracy, as it were, with regards to the introduction or the incorporation of certain reproductive, uh, um, uh, yeah, the things that bring down the reproduction, we are also able to confirm. So, but without that, the people raising these conspiracy theories should not be blamed. We don't have data
exactly
to show that this is there. We don't have data to show that it is also there. So the conspiracy theories are right, and our silence is not golden.
All right, sir. So we have a question here. He said, please, he said, first of all, he said, well done, sir. Please, I want to ask, is it only the government that has the capacity to sponsor vaccine production? Another question following it is that what other means can vaccine production be revamped in the country?
Yeah. Okay. Yeah, so vaccine production is capital intensive. Individuals have tried it, but issues would always come. Even outside of this country, if you look at what is happening, no government, as it were, is fully involved. The American government has already given this company, what's the name again, a pharmaceutical company, funds to generate doses of vaccines that will cover their people. So the government of America is not in the production. But do we have conglomerates in Nigeria, in Africa, that will come together? The process is hectic, like I have said. First of all, is in the development, but the process of the production is a routine. We can do the routine production, but development proper, for example, if you have been the one putting in money for the development of HIV vaccine and nothing has come out, do you know how much has sank in there? Or of Lassa, do you know how much has gone in there? So these are the constraints. But with regards to the production, if we have the protocol already established, our own is to fetch 2 meals of this, add it to this, whatsoever meal of this, add it. For the conventional vaccines, we can do that. DNA or reverse vaccinology, we may not have the capacity at the moment.
Wow. We are backward really in medicine and technology.
Infrastructure.
It's really frustrating. Like I keep saying that Nigeria has everything it needs to succeed. But it's just that our perspective to life will not allow us to succeed. We often don't see the bigger picture. We often don't see the. And anyways, thank you very much, sir, for availing us your time. For us here at.
Let me add this. For us in NVRI, we are into the production of animal vaccines. And we have been able to sustain that, both viral and bacterial vaccines. Now, whatever made the federal government to fold up the human vaccine production laboratory in Yaba is what still leaves a lot of questions to be desired. There are challenges may crop up, but of course, it's a human system. We can rally around to resolve those challenges and move on. So if you are talking about capacity, the Nigerian scientists have the capacity. In fact, for your understanding or for your information, most of the people in the vaccine production laboratories in NBRIVO, they are medical laboratory
Wow.
technicians. Well, yes, because like I have said, it's just a routine, it's a
Okay.
protocol. Where where the work is in the research and
Okay.
development. And some of us that are in the research laboratory, that is the work that we do. We research into vaccines that would be developed, and the moment we have standardized them, they have been developed, we push them to the production aspect with the protocols so that they can just follow the process and get it done. So the production is
All
not any
right.
big
There's
deal.
another question here. It says, I think we just do this in less than a minute. Say, what are the possibilities and areas in
Okay.
which AMSEN can provide assistance in helping medical laboratory science professionals get into vaccine production routinely or development? Does AMSEN have such capacity?
Yeah, so first of all, AMSIN can, through
Okay.
MLSCN, talk about the reorganization of our
Okay.
curriculum, right? To provide the basic knowledge there. The second thing is to push through the Federal Ministry of Health and uh, the Primary Health Development Agency to have these laboratories mounted for the purpose of quality assurance of our vaccines. The most of these places that we have, our people will go there for bench placement, for internship, for other activities, and then they will build the practical
Okay.
capacity.
All right. Thank you so much, sir. This is the much we can take on this session. We still have
Okay.
another session going that's going to continue immediately we cut off from here. Thank you very much. We appreciate your time, your wisdom you've shared with us. We believe that a lot of people out there they've come to a better knowledge of vaccine production in Nigeria, as well as the limitations and the challenges, and also how we can mitigate against those challenges so that we can move forward. And this actually a part of this summit to open our eyes to the possibilities, because I believe that there are infinite possibilities to what we can do as individuals, first as
Exactly.
individuals, then we now begin to talk about as collective individuals. Thank you very much. We don't take your commitment to this work lightly. We appreciate you for joining in. Thank you very much, sir.
I appreciate it. Thank you for having me.
Hello, everyone. We just finished a session with Dr. Solomon Chollom. We'll be expecting to get into another session with scientist Chidindu Mmadu-Okoli. As soon as she comes online, we put her through and we'll get on her section.